So a block of copper has a mass of 2 kilograms and it absorbs 12,000 joules of energy. The specific heat capacity is 385 joule kilogram degree centigrade. Remember one thing, whenever a question is there related to the specific heat capacity, thermal capacity, or latent heat.
Mr. Sorry.
Yes.
Mr. Can you repeat question 10?
Okay. Look, in question 10, we have to tell the advantage of thermocouple. So what is the advantage of thermocouple? A thermocouple consists of a millivoltmeter, two wires which are coming out from the voltmeter are made up of same material, and the two wires are connected by another material. One is called a hot junction, another one is known as the cold junction. Because it consists of the metal, so with an instant or a very short time interval, it can measure the voltage, and we can use this voltage to determine the temperature. As compared to liquid in a glass thermometer, so when there's a liquid inside a glass thermometer, it will take time to show a change in temperature. Like thermocouple only take about 2 seconds to show a change in temperature, where on average liquid in a glass thermometer take 8 seconds to show a 1 degree change in temperature. So which is more, which is responding quickly, or which is quick acting? So thermocouple is quick acting as compared to liquid in a glass thermometer. So what is the advantage of using a thermocouple instead of liquid in a glass thermometer? That thermocouple can measure a temperature change rapidly. Rapidly means very fast.
So, Mr. It's not more sensitive?
Sensitivity of a liquid in a glass thermometer can be changed. We can make it more sensitive. Liquid in a glass thermometer sensitive, we can make it more sensitive as compared to thermocouple. The best advantage of thermocouple over the liquid in a glass thermometer is it can measure a rapid change in temperature. Thermocouple is sensitive. Liquid in a glass thermometer is also sensitive. So both have sensitivities. But the advantage of a thermocouple over a liquid in a glass thermometer, it can measure a rapid change in temperature, a fast change in temperature as compared to liquid in a glass thermometer.
Yes, okay, miss.
Then a block of a copper has a mass of a 2 kilogram, energy is 12,000, and specific heat capacity is there. So we have the formula, the specific heat capacity is energy divided by mass into temperature change. Or if we need it, or we have the formula E is equals to Cm delta T, you can also use this formula to work out temperature change. E is the energy, which is 12,000. One thing you have to keep in mind, if specific heat capacity is joule per kilogram, the mass should be in kilogram. Some question, this is in joule per gram, so the mass should be in gram. So specific heat capacity, it's 385, the mass is 2, and the temperature change we don't know. So this 385 and 2 are multiplied, other side will be divided. So 12,000 divided by 385 into 2. This will give us the temperature change for this copper, which is 15.6 degree centigrade. Demonstrate an experiment to a class. A boiling tube is filled with water and some ice cubes are trapped, as you can see here, and there is a metal mesh. Metal mesh means a metal net is there. So because ice tend to float on the surface, so this metal mesh will keep the ice at the bottom. And a teacher is supplying heat energy to the top. The teacher then heats the boiling tube in the position shown. The ice does not melt. What does this demonstrate? So water at the top start to boil, but the ice is not melting. So what is the reason? What it shows? It shows that the water is not a good conductor of thermal energy. If water was a good conductor of energy, then what will happen? The ice will start to melt as well. So this shows that water is not a good conductor, or water is a poor conductor of heat energy. Question 13. A metal cup has a plastic lining. As you can see, the cup is filled with a hot water, which is held by the hand. So there's a cup, plastic cup is there, which contain a hot water inside. And a person is holding this cup. Which statement about the transfer of thermal energy from water to the hand is correct? So basically, how the thermal energy or heat energy is transferred from water to the hand. So when we check, this is a metal cup is there, which is having a plastic lining. What does it mean? Like it means a metal. This cup is made up of metal, and there is a layer of plastic. That's called a plastic lining. So in plastic, no energy transferred directly between the adjacent molecule. So that is not correct. Even plastic is a poor conductor, small amount of energy will transfer. Here it is written no energy transfer, that's why it is wrong. In plastic, fast moving molecule interact with the free electrons. In a plastic, it's an insulator, like it is a poor conductor or insulator. It does not contain a free electron, that's why B is also wrong. In metal, energy is transferred by electrons only, that is also wrong, because metal consists of a lattice of a positive ion and the delocalized electrons. So the lattice of a positive ions and the delocalized electrons, that's how the metal can conduct electricity, by transfer of the electron and the vibration of the lattice vibration. So in metal, the energy transferred by electron and by vibration of the lattice, that's why D is the right answer. So not only electrons are there, which are responsible for transfer of heat energy in metals, but there is a lattice vibration, and most of the energy is transferred by the lattice vibration, and small proportion of energy is by the movement of electrons. In question 14, the structure, a U-shaped tube with a constant cross-section area. It is filled with water, which is having a density of 1000 kilogram per meter cube. Both sides of a U-tube are open to the atmosphere. So both sides are open to the atmosphere. Then the atmospheric pressure, as you can see here, then we connect a gas syringe. The left-hand side of a tube is now connected to a gas supply. So there's a gas connected. We have to calculate the pressure of the gas supply. First, when you see this side, the atmosphere is there, pressure of the atmosphere. This side, the gas is exerting pressure, and due to the difference in the level, the liquid is also exerting pressure. So we can say that the pressure of the gas equals to pressure of liquid plus pressure of atmosphere. So pressure of the gas, which is on the left-hand side, is equals to pressure of atmosphere plus the pressure due to difference in the level. So if this is 0 and the level, what we take a difference in the level. So this is 0.2 down, this will be 0.2 up. So the total level difference is 0.4. So this will be 0.4 meters. So pressure of the gas equals to pressure of atmosphere plus pressure of a liquid, and liquid pressure or pressure exerted by the liquid given by a formula: density of a liquid, gravity, and depth. And this depth is a difference in a level in a manometer. So pressure of a gas is pressure of atmosphere, which is 1 into 10 to the power 5 Pascal, plus the density, which is 1000, multiplied by gravity, which is 10. 9.8 is the exact value, but you will take as 10, and multiplied by the depth, which is a difference in the level, so equals to 0.4, because 0.2 down, 0.2 up, so the difference in the level is 0.4. So when we multiply all these factors, we'll get the pressure of the gas, which is 1.04 into 10 to the power 5 Pascal. So some of the students, they only calculated the pressure of the liquid, which is density, gravity, and depth, and they say that is the pressure of gas. But that is not correct. Why it is not correct? Because the gas pressure, according to this figure, the gas pressure is atmospheric pressure plus the liquid pressure. So the difference in the pressure is the gas pressure. So the total pressure, left hand side, there is the gas pressure. So we can say pressure of a gas. On the right hand side, there is the atmospheric pressure. So pressure of atmosphere. And there is a liquid pressure. So pressure of liquid. Pressure of atmosphere is already given 1 into 10 power 5 Pascal. So this is 1 into 10 power 5 Pascal. Plus the pressure of a liquid. How to calculate the pressure of a liquid? That is the density of a liquid, gravity, and depth. Density of a liquid is 1000, gravity is 10. And what about the depth? Depth is actually the difference in the level. So if it is 0.2 down and remaining 0.2 up, so what is the difference in the level? That will be equal to 0.4, because 0.2 plus 0.2, that's equal to 0.4. As it goes 0.2 down, other side it rises 0.2 up. So the difference in the level will be 0.4. So when we multiply this, this will be 4000, because 10 into 4.4 is 4, and 4 multiplied by 1000, this is 4000. So this is 4000 and this is 100,000. So when we add them, the total pressure will be 1.04 and 20, or 104,000 will be there. If 104 or 1.04 into 10 to the power 5 Pascal. So that is a total pressure which the gas is exerting. Then the next part is actually related to the previous part. So now the gas which is shown, as we already calculated, the pressure of the gas, the pressure exerted by the gas, we already calculated, that is 1.04 into 10 to the power 5 Pascal. The figure 3.1, the figure 3.3 shows the gas supply is now connected to a cylinder. So this is connected to a cylinder that containing a piston. The pressure of a gas moved the piston to the right hand side. So area of the piston in contact is 0.025. Calculate the resultant force. Look, we already calculated that the gas is exerting the pressure of the gas, which we calculated, that was 1.04 into 10 to the power 5 Pascal. That is causing a pressure this piston to move towards the right hand side. And the pressure of the atmosphere, because it is open to atmosphere, that is 1 into 10 to the power 5 Pascal. So pressure of the atmosphere is 1 exponent 5 Pascal, and the pressure of the gas, which we calculated in the previous part, that is 1.04 into 10 to the power 5 Pascal. So what is the difference in the pressure? The difference in the pressure will be 1.04 into 10 to the power 5 minus 1 into 10 to the power 5 Pascal. So the difference in the pressure will be equal to 4000 Pascal. So 4000 Pascal is actually the pressure which is exerted by the, because on the left hand, from the left hand side, there's a pressure of, towards the left hand side, there's a pressure of atmosphere, and towards the right hand side, there's a pressure of a gas. But because the gas pressure is higher by 4000, as a result, so what is the resultant pressure here? The resultant pressure is 4000 Pascal, and they give you the area, which is 0.025. So to calculate the force is pressure multiplied by area. So the pressure was 4000 multiplied by area is 0.025. So when we multiply them, we will get the resultant force, which will come out as 100 Newton. So the difference in the pressure is the resultant pressure, and resultant pressure multiplied by the total area will give us the resultant force. and the pressure of a gas causes the piston to move a distance of 0.5 to the right hand side. Calculate a work done by the gas from the supply on the piston. So work done is a force into distance. We already calculated the resultant force, which was 100 Newton. So work done is force into distance. The force is 100 and the distance is 0.5. So it will be 50 joules. Yeah, there are two ways to calculate this work done, because work done by the gas is having two formulas. One is a normal work done, force into distance. And there is also another formula for work done by a gas, that is pressure into volume. So pressure into volume, when you multiply the pressure with volume, you will get 1300 joules. Both answers are acceptable. If you write 50 joules, that is correct. You write 1300 joules, that is also correct. Because in O levels, you're not actually the correct answer should be 1300. According to the physics law, 1300 is the actual answer. But because you did not study in O levels, you're not studying this formula that the pressure exerted by the gas is pressure into change in volume. That's why they accept that you get 50 joules as an answer. So they accept this answer as you are using a formula which you have already studied. So both ways it is acceptable. You can right? But because in IGCSE O levels, you're learning a formula for work done, that is force into distance. So you, according to that formula, you will get the answer 50. But there is also another formula to calculate a work done by the gas, which is pressure into change in volume. That will give you 1300. So even if you get answer 1300, they will award you the mark. You get the answer 50, you will also get the marks. In question 15, a large test tube containing a liquid at room temperature, an electrical heater is immersed into a liquid and switched on. The thermal energy is supplied to a liquid by a heater. The temperature of a liquid increases until it reaches the boiling point. The liquids then start to change to gas. Describe in terms of molecule and their motion how the liquid differ from gas. So molecule and motion. So in liquid, the molecules are closer compared to that of gas, and in liquid, the molecules can slide over each other. Where in gases, the molecules are moving randomly. Describe what happened to a molecule of a liquid when
Mr. Sorry, can you write it again?
Look, what happened? What is the question is, what is how liquid differ from a gas in terms of molecule and their motion? So in terms of molecule are closer in liquid, and in gases they are far apart. And molecules in liquid can slide over each other, like slip pass over each other or slide over each other, where molecule in a gas are moving randomly. They're continuously changing the direction or moving randomly at high speeds.
Yes, okay, thank you, sir, clear.
Describe what happened to a molecule of a liquid when its temperature began to increase. So whenever temperature increase, what happened to a molecule? Molecule will move faster and they will move away from each other, because that's the effect of increasing temperature. So the particle will move faster and they will move away from each other. Explain in terms of molecule why a supply of a thermal energy is needed to change a liquid into a gas. So what is the reason why we have to supply energy to convert liquid into a gas? So basically energy is needed to break the bonds, the intermolecular. Yes, you can say increase in kinetic energy. That's also correct. The previous answer, you can mention that it can also be used to increase the kinetic energy. That is correct. That is actually written in the marking scheme. They also write increase in kinetic energy is also correct. So energy is needed to break the bonds. The density of a liquid in a test tube is 0.86 and the volume is 50. Look, density is gram per centimeter cube, volume is in centimeter cube. So we'll get the answer in grams. To get the latent heat is energy divided by mass. It's up to you. You can take mass in gram or kilogram. So density is mass present in a unit volume. So mass is equals to density times volume. Density is 0.86 and the volume is 50. So when we multiply them, we will get 43 grams. So 43 grams of substance is there. Then the energy, it is 18,000 joules divided by 43. So 18,000 divided by 43. This will give us 420 joule per gram. Or you can also convert it to kilogram, but this will be 18,000 divided by 43, which is 418, sorry, 418.6. So 418.6 joule per gram. Marking scheme, they write 420 as they normally use the rounded off answer in the marking scheme. Then a metal container is used to cook food. The metal container has a thick walls, hot cooking oil at temperature of 120 is poured into a container. The outside surface of a container gets hot. Some of the thermal energy passes through the metal because of vibration of atom in the metal collide with a neighboring atom and transfer them. Explain how the rest of a thermal energy is conducted through the metal container to the outside surface of by another process. So basically what happened, like a conduction happened here. That is one thing. The second way the conduction happened, because what is a conduction? Conduction means is a transfer of the heat energy by the lattice vibration and the collision of the delocalized or the free electrons with the lattice as well. So the delocalized electron, they move one from place to another and they also collide with the lattice and transfer the thermal energy. So how the rest of a thermal energy is conducted through the metal container to the outside surface of by another process. Basically, they don't mean like convection here or radiation. They mean what happened in a conduction. What is the second thing happen in a conduction? So the electrons actually travel from a region of a high temperature to a low temperature and they collide with molecules or the lattice or the ions which are far from the source. So one mark is for mentioning that electrons move, like movement of the electron, and these electrons travel from one place to another and they hit the positive ions or electrons far from the source. So electrons, the second method process which is responsible for a conduction, that electrons movement. Okay, I will explain the wave, then no problem. So electrons movement is there. They collide with the ions and electrons far from the source. And they transfer energy. The outside surface of a container is brightly polished and shiny. Explain how this reduces the power that need to be supplied to keep the oil at a correct temperature. So as we know, dull and the shiny surfaces are good reflector. They are poor absorber or emitter, and they're good reflector. So it does not lose the energy. The shiny and the polished surfaces, they are good reflectors. So reduce the heat energy or reduce heat loss from the container. So container will remain hot for a longer period of a time, as you have seen, like a thermo flask or thermos. The inner wall of a thermos is very shiny surface, a silver layer is there. The main advantage of a shiny surface, it reflects the heat multiple times so that the substance will remain hot for a longer period of a time. The metal container is spherical. So you can have a container cylindrical or spherical. Spherical container have a small surface area than a long thin container of a same volume. So they're saying explain advantage of using a spherical container. So spherical container, because it will have a small surface area in contact with the surrounding, so the thermal energy which is lost, the rate of heat energy loss will be reduced. Then
Mr. So we will
yeah,
write what? Sorry.
you will write the thermal energy because spherical containers have a small surface area. So small surface area means the rate of heat loss will be. So small surface area, so it will have a rate of heat loss reduced or lower. So it will remain hot for a longer period of a time. Like maybe you have seen some of the pots, the bottom of the pot is slightly spherical, curve, rather than a flat. So advantage is that the uniform transfer of heat energy and it loses heat energy at a slower rate. In question 17, a student carries out experiment using a plastic beaker that contains 0.24 kilogram of water at 17. The thermal capacity means energy required to change the temperature. Better learn the standard definition. Energy required to change the temperature by 1 degree centigrade. That's called thermal capacity. Several ice cubes are at temperature 0. The ice cubes are dropped into a water and internal energy of a water decrease. Give a simple molecular account for this decrease in internal energy. Why the internal energy? Internal energy is actually a sum of kinetic and potential. So what happens when we add ice cubes to water? So ice cubes will gain energy from the water because ice cubes are at low temperature. Water will be even water at room temperature will be at a high comparative to the ice cubes. So the energy is transferred from the hot object to always to a cold object. So the water will lose energy to the ice cubes. As a result, the water molecules will move slower. So we have a container and we drop the ice cubes into a container. So what happened? The water molecules will lose energy to the ice cubes. So the temperature of a water will decrease. And how the internal energy decrease? Internal energy is a sum of kinetic plus potential. So as the particles, as the water molecules are losing energy to the ice, the kinetic energy or speed of the molecule decreases. So the internal energy will also decrease. So here the answer, when you write the water molecule lose energy, and move slower. As a result, when they move slower, the internal energy will decrease. Then the specific heat capacity of a water is 4,200. The temperature change is 17. Calculate the decrease in internal energy. So we have to calculate energy. So we have the formula E is equals to Cm delta T. Specific heat is 4,200. M is the mass of water that
Mister, can you write the formula again? Because I didn't take a screenshot.
I will write. I'm just copying the.
Yes, okay, sir.
So it's 0.24 kilogram of water is there. So that is the mass of the water. So the energy lost and energy transfer whenever there is a change in temperature. So we have the formula E equals Cm delta T. Yeah, so final answer will be 1.7 exponent 4. So E is equals to Cm delta T. Specific heat is 4,200. The mass is 2.4. And the temperature change 17 to 0. So that is 17 minus 0 or 17. When we multiply them, we'll get 1.7 exponent 4 joules. So 1.7 into 10 power 4 joules of energy is actually lost by the water. As the temperature of a water decreases, some of the ice melt. Explain why this ice melt. So what is the reason why the ice melt? Because ice gain the particles which are there in ice, they gain energy and they break the intermolecular forces. So the energy absorbed by the particles of ice or energy lost by the water.
So, Mister, it causes separation between the molecules.
Yeah, basically break the bond between the molecules, so the molecules separated and the ice melt. So energy lost by water is gained by ice and it break the intermolecular forces. The molecules. As a result, when it breaks the intermolecular force, the ice will melt. Then describe how you determine the latent heat of fusion of ice using this apparatus and state any other measurement. So the formula to get the latent heat is energy divided by mass. So we have to calculate the energy and we have to calculate the mass. So first we'll state any measurement. So latent heat is energy divided by mass. We'll get the energy by using a formula Cm delta T. That is the energy, because the energy lost by the water is same as the energy gained by the ice. And M is the mass of the melted ice. So we will measure the amount of the ice which is melted before and after. So the steps which we will mention will determine the mass of the ice. And the temperature should not change. So the mass of the melted ice, and we'll maintain the temperature should be constant for this reaction. So we'll measure the temperature. That should be constant. And the third mark is for using a formula that latent heat is energy divided by mass. The main reason why we are measuring a temperature is just to make sure that the temperature is not changing. If the temperature changes, the ice will melt. Then in question 18, figure 3.1 shows a balloon which is inflated with air, explained in terms of momentum. Why there is the pressure? So in terms of momentum, the gas molecules are moving randomly, they changes the direction, and change in direction cause a change in momentum. So here the gas molecules moving randomly. They change direction. As they change direction by colliding with the wall, change in direction because momentum is a vector quantity, it changes the momentum. Exert force, and when they exert force on unit area, it will create a pressure. Then we have to use a Boyle's law, P1 V1 equal P2 V2. So P1 V1 equal P2 V2. So this is a V1, this is P1, this one is P2, and we'll substitute, I'll get the value for V2, which will about 450 centimeter cube. So whenever a gas there at a fixed temperature, the P1 V1 equals P2 V2. And the balloon and a stone stop moving when the stone hits the bottom of the lake. The temperature of air now begins to decrease. Why the volume of air in the balloon decreases as the temperature decreases? So as the temperature decreases, the particle will move slower. The gas molecules will move slower, so they will exert less pressure and less collisions will be there as a result. So why the volume of air in the balloon decreases? So temperature decrease in temperature. So particles move slower. And as a result, they will exert less pressure. And when they exert less pressure, the volume will decrease. The alternative to practical, we already discussed the experiment. So this was a block 2 test, the thermal physics.